So, overview of air pollutants is most of the air pollutants that we'll be talking about are going to come from combustion, and in particular, combustion of different fossil fuels. So, the first one up here says write the equation for complete and ideal combustion of octane. So, octane is often what we use to model gasoline. Gasoline is actually a mixture of a whole bunch of different hydrocarbons, but the basic formula for combustion, which you should know, is C8H18, or this is my octane, which is given, and then plus oxygen gives CO2, water, and energy. If I were to balance this, I would balance this to balance my hydrogens. I'm going to put a 9 here, which is going to give me 18 hydrogens there. Then to balance my carbons, I'm going to put an 8 here. And then in the end, I'm going to have 8 times 2, 16, plus 9, which is going to give me 25. So I'm going to actually do 12.5 in front of this, which I can do because O2 is a diatomic, or the other way I could do it is 25 halves. And so I could do half of an O2, which would just be an O. So that would be the equation for complete and ideal combustion of octane. Now I'm going to do the exact same equation below, and I'm now going to be talking about carbon monoxide. But instead of just having CO2, which if I burn and just get CO2, I'm going to get the most energy, and I'll just do E for energy. But I'm also going to do this here, the exact same formula. And when I do this one, I'm going to balance my 7 CO2 and 1 here, and I'm going to do 1 and 7 here. So you'll notice my carbons will balance. My hydrogens will balance the same way with the 9 there. And now just to balance my oxygens. So here I have 7 times 2, 14, plus 1 is 15, plus 9. So 15 plus 9 is 24. So this is going to need 12 oxygens. Versus down here to balance it, I'm going to need 2 plus 7, 9, plus 9, 18. So this is only going to need 9 there. So notice this here is carbon monoxide. When I make more carbon monoxide, so more carbon monoxide is formed when there is less oxygen. So we talk about incomplete combustion causing carbon monoxide, and it's basically when there's less oxygen present. So this is the type of things where they'll say for indoor air pollutants or outdoor air pollutants, incomplete combustion, meaning not enough oxygen present. So if I put boxes around my hot water heater and then I end up with issues with carbon monoxide, I was maybe blocking the air intake into my hot water heater or my device, and so that was what was causing or could be causing the carbon monoxide. So again, goes back to chemistry. You're not going to have to balance these equations or think about that, but again, the big idea here, if there's less oxygen or the oxygen limits the combustion, I could form more carbon monoxide, and that's the idea of incomplete combustion. The next one is the idea of where sulfur can come from, and it's again whatever we put in is what goes out. And so here I'm going to do the exact same thing here and energy, but I'm going to also do SO2 or SOx because any element that goes in here has to come out somewhere over in the product side. So I'm having it come out in my SO2. So again, I can balance this equation if I want to in a variety of ways. Maybe there would also be some carbon monoxide in here. But the big idea is if my fuel has some sulfur in it, then sulfur must come out the exhaust. And typically it's going to be in a gaseous form. And so whatever we put in has to come out. Law of conservation of matter. So if I do a fuel with more sulfur in it, I'm going to have more sulfur oxides. This is with sulfur. One of the ways they've reduced sulfur dioxide or SO2 or SOx emissions is by using low sulfur diesel. What is low sulfur diesel? It's diesel fuel with less sulfur in it. If less sulfur is in it, less sulfur is going to come out of the exhaust pipe. Last, same basic idea, but now with nitrogen in it. Now, one of our big sources of NOx is from high combustion or combustion at high temperature and pressure, which is just from the air intake. But same basic idea too, is whenever I burn a fuel that has some nitrogen in it, so here coal has nitrogen in it. When I burn this, what has to come out is some nitrogen has to come out. So if I put it in, so here, if the fuel has N in it, then N, or in this case the NOx, must come out the exhaust. So big idea, conservation of matter. So what's a way to reduce this? Well, if I burn natural gas is just CH4. It really has no N in it, no nitrogen in it, and so I'm going to reduce my emissions of NOx. However, do remember, even if it's a natural gas engine, a combustion at high temperature and pressure, because the air has nitrogen gas and oxygen gas, that will end up forming NOx also. But again, just thinking about the fuel source, if I change the fuel and it has no nitrogen, then I won't have NOx coming out the exhaust primarily. So that is the idea of air pollutants and just your combustion equations.